Okay, ma? So next topic is Newton's law of cooling, ma. So direct questions will be asked on this equation. Very important topic for Neet and mains examinations. Okay, see, ma. So it says that the rate of cooling of a body is directly proportional to temperature difference between body and the surroundings. It means that when compared to surroundings, what is meant by T naught here? T naught means temperature of surroundings. Okay, ma? T means temperature of body. Okay. So what does it say? If temperature of the body and temperature of the surroundings, this difference, if it is large, then the rate of cooling of a body is also large. Are you able to understand? So dT means what? Change in temperature, not heat energy. dT means change in temperature. Here small t means change in time. So if temperature difference between a body and surroundings, if it is greater, then that body cools down very fast. That is the meaning of it. Are you able to understand? You should have observed this one in bathing with hot water. So if you heat the water to a temperature of 100 degrees Celsius and if you pour in bucket, so within very less time, this temperature reaches from 100 to 80. Within 2 or 3 minutes, temperature comes down to 80. Are you able to understand? But to cool from 80 to 60, it will take a lot of time. Are you able to understand? Similarly, to cool from 60 to 40, the time taken is very, very, very large. Are you able to understand what is happening? Temperature difference between body and surroundings, if it is greater, then that body cools down very fast. Temperature difference is lesser, then temperature also reduces very slowly. Okay, ma? So this law is called as Newton's law of cooling. So how we write in the form of the statement, Sima, dT means change in temperature. dT means change in time. This is directly proportional to difference of temperatures. This is temperature of the body, this is temperature of the atmosphere. Okay? And if you do some manipulations to this equation, then this is a final ready-made equation which we will get. And the derivation of this equation, we are not supposed to remember, ma. Just remember this equation. Understood, no? So here, T1 is initial temperature of the body, T2 is final temperature of the body. And small t is the amount of time taken. Okay? And T naught is called what? T naught is called as temperature of the surroundings. And K is any constant. Is it clear? So these values you should remember. So write down. T1 means what? T1 means temperature of or initial temperature of body. Initial temperature. Okay, ma? T2 is called what? T2 is called as final temperature of the body. And T0 means temperature of the surroundings. Small t means the time interval. Small t is called as time. Okay, ma? And K is called as any constant. Understood, no? That's it. Make a note of it. Okay? See, ma. So temperature of a body falls down from 40 degrees Celsius to 30 degrees Celsius in 10 minutes. Okay? So in 10 minutes, temperature falls from 40 to 30. Now, what is the temperature of the surroundings? 15 degrees Celsius. Then the question is, find the time taken for temperature of the body to become 20 degrees Celsius. Okay, ma? 20 degrees means from 30 to 20 or from 40 to 20. Let us see in the question, ma. 30 to 20, I think. Okay, ma? So let us see what is the data given. So for temperature of the body to fall from 40 to 30, time taken is how much? Time taken is 10 minutes. Are you able to understand, ma? Then what is the question he is asking? Time taken from 30 to 20 degrees Celsius, this time I am supposed to calculate. Understood, no? Is it clear? Same body only. To reach from 40 to 30, it will take. Then from 30 to 20, how much time will be taken? So initially, do some guesses, ma. Will it be greater than 10, less than 10, or equal to 10? Huh? It will be greater than 10. Why? Because what is the temperature of surrounding? 15, no, ma? And 40 minus 15, it is a bigger value. Temperature difference is large, no? 40 minus 15 is how much? 25 degrees is the change in temperature. Okay? But now temperature is 30. And what is the difference between 30 and 15? So change in temperature is equals to 15 degrees Celsius. So where temperature difference is greater, here temperature difference is greater. So here time taken will be lesser. Understood, no? That's what we studied, no, ma? If temperature difference is greater, body cools down very fast. It means the time taken to cool down will be lesser. Okay? So now let us see how can I do this calculation. So what is Newton's law of cooling, ma? So T1 minus T2 divided by T is equals to K into T1 plus T2 by 2 minus T0. This is the relation, no? Clear, no? But K value do I know? K value I don't know. So what can I do? So write one equation for first condition, write one equation for second condition, divide both of them, then you will can get rid of K value, no? That is the method in which I have to do. Is it clear? Just dividing first equation and second equation. So write down. So what is the initial temperature of the body? 40. Final temperature is how much? 30. Shall we convert this one into Kelvin scale? Kelvin scale, shall I convert? Let us see, is there any necessity to convert into Kelvin scale or not? No need of converting, I think. No need of converting into Kelvin scale, because all the conversions, they will get cancelled, no? So no need of converting into Kelvin scale, directly you can write. So T1 minus T2 divided by, what is the time taken in the first condition? 10 minutes. So this also you need not convert into seconds, because conversion factors will get cancelled with each other. So this is equals to K into T1 plus T2, 40 plus 30 by 2 minus, T0 means temperature of surrounding. What is the temperature of surrounding? 15. Okay. So if you do this calculation, what I will get? So 10 by 10 number, 10 by 10 is 1. 1 is equals to K multiplied by, so 70 by 2 is how much? 35 minus 15. So therefore 1 is equals to K into 35 minus 15 is 20. So K value directly I got very easily. So no need of dividing both the equations. K value directly I got, it is 1 by 20. Clear? Now you go for case number 2. Case number 2. What is case number 2? Again write the same equation. T1 minus T2 by T is equals to K into T1 plus T2 by 2 minus T0. Clear, Nama? So now what is the initial temperature? 30, no? Now initial temperature is 30. So 30 minus final temperature should be 20 divided by time taken, I don't know. So this is equals to K value, already I have calculated 1 by 20. Initial temperature is 30, final temperature is 20 divided by 2 minus, what is the temperature of surroundings, 15. Okay. So just do this calculation and calculate the time taken, that is my answer. Okay. And the answer which you should get is 20 minutes. So check whether you get this answer or not. 20 minutes. Okay. See, my time has increased very large, no? Initially it was only 10 minutes to cool from 40 to 30. Now here in second case also temperature difference is same, 10 only. But see what is the time taken? Time taken have doubled. Okay. That is called as Newton's law of cooling. Okay. See, ma'am. The last topic in heat transfer, Sima, Weins displacement law. Sima, when a body is heated, which body? When a black body. Here, ma? When a black body is heated, it releases radiations, it releases all the radiations. Ma. All the radiations means what? Radiations at every wavelength. So all the radiations will be released at the same time. But there will be one wavelength at which maximum energy will be released for a particular temperature. Are you able to understand what is the meaning of this one? So at different temperatures, there will be different wavelengths where energy released will be maximum. All wavelengths will be released, but at one wavelength, energy released will be maximum. And that wavelength depends on temperature. Okay? How they are dependent? If temperature increases, okay, ma? That wavelength where maximum energy is released, that reduces. They are inversely proportional to each other. Okay? Lambda m means what? Lambda m means wavelength at which maximum energy is released. Maximum energy is released. Are you able to understand? Ashish student సంతలో తప్పిపోయిన పిల్లోళ్ళలాగా ఉన్నాడు. అలిసిపోయాడు పాపం. ఏంద్ర ఇది ఇసిపెట్టాడు ఎదురా క్లాస్ అని. Okay, Sima. So the wavelength at which maximum energy is released and temperature, they are inversely proportional to each other. So if you remove this proportionality symbol, I have to write a constant, that constant is called B. So lambda into T always remains constant, and that is B. For anybody, for any temperature. Understood, Amma? And what is that constant? That is called as Weins constant, and its value is 2.89 into 10 power minus 3 meter into Kelvin. Okay. Now let us draw the diagram of this one. How can we represent this one in the form of a diagram? So this is wavelength released. This is temperature. Okay, ma? On y-axis we are taking the wavelength which are released, and with respect to temperature. With respect to temperature, no ma. With respect to temperature, I don't think we should take this one. So relation between energy and lambda. Okay, ma? Energy released and lambda. Okay, I think we have to take a relation between these two, energy and lambda. Okay, see how I can draw this graph is, this is my first graph. Okay, ma? This is my first graph. So here body is heated to a temperature of T1. Are you able to understand? Now what do you understand by this graph? So as a body is heated to a temperature of T1, okay, every wavelength is released, you know, ma? So this is 0 wavelength, this is the maximum wavelength. So every radiation of every wavelength is released. But there is one wavelength, clear ma, where energy released is maximum. On y-axis we are taking energy, no? So at one wavelength energy released is maximum. Remaining all wavelengths energy is less than maximum value. Are you able to understand? So if you heat a body, radiation of every energy is released. Every wavelength is released. But there will be one wavelength where energy released will be highest, maximum. Now what I do is, I rise the temperature of this body. I will increase the temperature of this body. Then what happens is that a graph will be somewhat like this. This is the graph I will get. So this is temperature T1 and this one is at temperature T2 and T2 is greater than T1. Okay, ma? Now can you say what is the difference between these two graphs? 2 maximum points. So for second graph, what do you understand? For second graph, I understand that now here I got maximum value, no? Clear, no? Now if you take this point, this is lambda m1, this is lambda m2. Temperature has increased, no? But what about wavelength? Wavelength has decreased. Wavelength decreased means what? That wavelength where maximum energy is released, that wavelength has reduced. Understood, no? Similarly, if I further rise the temperature of this body, then the next graph will be like this. Now this is temperature T3. Now what do you understand? So again every wavelength is released. Every wavelength is released. But there is one wavelength, okay, ma, where maximum energy released is present and that is again reducing. So this is lambda m3. Understood now what is happening? You rise the temperature. So that wavelength where maximum energy is released, that continuously reduces. Understood now? So this law is called as Weins law. Okay? And where it says that lambda is inversely proportional to temperature of a body. If temperature increases, lambda reduces. So product of lambda into T is a constant and this is the value of the constant. Is it clear? That's it. So in heating iron also you can call it as a black body. Ma. When you are heating iron, so these colors you can see, ma. VIBGR colors you can see. And when I move upwards, what happens to the wavelength? When I move from red to violet, what happens to the wavelength? Wavelength reduces. When I move away, upwards. What happens to energy? Energy increases. And when I move upwards, what happens to frequency? Frequency also increases. Because already we have studied energy of radiation depends on what? Energy is equals to h nu is equal to hc by lambda. This is the equation for energy of a radiation or energy of a photon also you can call it. Okay, ma? So energy is directly proportional to frequency, inversely proportional to wavelength. Okay? So if I move from bottom to top, energy increases, ma. Energy of violet color is very large when compared to energy of red color light. Energy of red color light is least energy. Energy of violet color is maximum. So energy is maximum, so frequency also maximum because they are directly proportional. Okay? But what happens to wavelength? Wavelength reduces from bottom to top because energy is increasing. Are you able to understand? Okay. So therefore, if you start heating iron మీరు హీట్ చేసినప్పుడు ఐరన్ మెటల్ వినోనమా when you put it in a furnace and if I start heating, initially temperature will be lesser, no? Temperature is lesser, so wavelength should be maximum, no? When temperature is less, wavelength should be maximum. So first of all, this iron converts into red color. చూసింటారు కదా ఎప్పుడన్నా? In villages you can see these scenes very often. Sometimes the color of the iron will be red, sometimes it will be orange, sometimes it will be yellow, and before melting, finally it converts into white color. Okay, ma? So initially it is orange. Why it is orange? Because temperature is very less now initially. So because temperature is less, wavelength will be maximum. And which one has highest wavelength? Red color has highest wavelength. Okay. Then if you continue heating, then iron converts into orange color. Then it slowly converts into yellow color. And finally it converts into light violet color. And finally it converts into white color. Okay. So that is what happens when you heat a black body. And this law is called as Weins displacement law. Understood, Nama? So very easily you can do problems on this one, no? How problems can be asked? Problems can be asked like this. Lambda 1 T1 is equals to lambda 2 into T2. So you compare lambda values and T values are different bodies, then very easily you can do the calculations. I don't think we need to discuss problems on this one, okay? So this completes our topic called transfer of heat energy, okay?